Friction is the force that resists motion when the surface of one object comes in contact with the surface of another. The mechanical advantage of a machine is reduced by friction, or in other words, the ratio of output to input is reduced because of friction. From matches to machines to molecular structures, friction is one of the most significant phenomena in the physical world.
Here are the problem statement. Arif are going to Johor Bahru on Sunday. He rushes to KLIA while pulling his luggage with a mass of 3 kg from his house to his car. On his way to the car, he goes through the rough inclined plane at 20 with acceleration of 1 ms-2. He put his luggage at 45 from the inclined plane with force exerted by his is 20 N. There are normal reaction R and frictional force Fc exerted on his luggage by the inclined plane. Find the coefficient of friction between the plane and his luggage. Here are the diagram and the free body diagram from the problem statement. We know that the acceleration are amongst the x-axis or the horizontal line. Since the mass are in kg, we will have to change the mass to weight. To find the weight, we will have to times the 3 with g, where the g are 9.81. From the free body diagram, we can find the solution of this problem statement. So for the vertical line, we know that the F up are equals to F down, or the summation of force up are equals to the summation of force down. There is two forces that goes up, which is R and 20 sine 45. So to get the summation of force up, we will have to sum up these two forces. Meanwhile, the forces down is 3g cos 20. Hence, the equation of total force up equals to total force down is R plus 20 sine 45 equals to 3g cos 20, and R plus 20 sine 45 equals to 3 times 9.81 times with cos 20. Then we will get R are equals to 3 times 9.81 times with cos 20 minus with 20 sine 45. Hence, R are equals to 13.5130. Since it is not in equilibrium, on the horizontal line we will have to use the equation of the total force are equals to mass time with the acceleration. The total force on horizontal line is 20 cos 45 plus with negative Fc plus with negative 3g sine 20. The force Fc and the force 3g sine 20 are in negative because they are on the opposite directions. Hence, the equation of total force on horizontal line are equals to MA is 20 cos 45 minus with Fc minus 3g sine 20 are equals to 3 times 1. 20 cos 45 minus Fc minus with 3 times 9.81 sine 20 are equals to 3. Hence, we can get the value of Fc are equals to 20 cos 45 minus with 3 times 9.81 times with sine 20 minus with 3. Hence, the Fc are equals to 1.0765. Fc is the frictional force that we can get by multiplying mu with R, where the mu is coefficient friction and R is the normal reactions. In this problem statement, we will have to find the mu or coefficient of friction. Therefore, we can get the mu by dividing Fc with R, where we will get 1.0765 over with 13.5130. Hence, mu are going to be 0.08.
Next is the second statement. With the same weight, what is the value of force exerted by Arif that will make sure the luggage move in the coefficient of friction between the plane and luggage is 0.90. As you can see from the slide, these are the diagram and free body diagram of the luggage. So here is the solution. We know that R is 13.513. So to get the frictional force, we use the friction force formula, which is Fc equals to nu multiplied by R. So as given in the problem statement, we know the coefficient of friction is 0.9 and we multiply it by R, which is 13.513, then we got the frictional force is 12.1617. Then we use the frictional force to know the force that exerted by Arif in the problem statement. So we use the formula of sum F equals to MA. So sum F is equals to F minus FC. So we insert all the values that we know, which is FC is 12.1617 and the mass is 3 kg and the acceleration is 1. So we solve it, then we got the sum F is 15.1617. In conclusion, friction is a basic force that affects many parts of our daily lives and technology. The application of friction in carrying luggage also plays an important role in the efficient and safe transportation of luggage. The friction between the wheels and the ground helps keep the luggage stable and allows it to move smoothly across various surfaces. The friction force also prevents slippage and potential accidents such as through crowded airports and uneven terrains. Furthermore, the frictional resistance between the handle and the user's hand provides a secure grip, reducing the risk of dropping the luggage. Knowing how to manage friction is important for making better technology, improving safety, and making things work more efficiently.